Hello all. Welcome to All About Java series, a beginner's guide to learning Java programming with me, Apurva Barve. As you know, this is the place where we are going to learn the fundamentals of Java programming through a series of easy to understand lessons. In the previous lesson, we coded our first ever Java program and tried to understand some basic concepts of the source file, class file, main method, and the constructs that go into writing a program. In today's lesson, we are going to cover the decision makers of Java. These are the if statement. We are going to cover different combinations of it and the switch statement. And while we understand the syntax of the switch statement, we will also take a look at the evolution of the same over different versions in Java. So, why wait? Let's deep dive. Just like we decide a course of action after carefully considering the options at hand, so do our programs. The decision makers, which are available in any programming language, help the program to choose the next direction of execution depending on how the conditions evaluate. And all this happens at runtime, dynamically. Let us first discuss the simplest form of if statement. You will know after the completion of this lesson that else if ladder, and switch statement together contribute the decision making aspect of Java language. So, how does a simple if look like? Let's say we have this int variable n, which is assigned a value 10. We pass this variable to the if condition. Notice how the condition is written. It is put into the parenthesis. It can have one single condition, or there could be more than one conditions, which are connected using bitwise or logical operators. In our example here, we have just one. No matter how many conditions are put together in the if statement, every condition is evaluated for its Boolean value. The Boolean value could be true or false. And then depending on the total value of the conditions or condition within the if statement, the course of action is decided. So let's say that here, if the value of n is completely divisible by 2, I want to print n is an even number. Please notice that in the first statement, I'm assigning n a value using a single equal to sign. And in the second statement, I am comparing the value using double equal to sign. So double equal to is the comparison operator, whereas single equal is an assignment operator. Many times coders make silly mistake here by using a single equal to instead of using a double. Anyways, so coming back to the basic format of if statement, I pass it a value, I use one condition, and if the condition evaluates to true, I want the program to do a certain thing. However, what if I want the program to do something if the condition evaluates to false? That is, if n is not totally divisible by 2. If that is the case, I want the program to print that n is an odd number. So what we're seeing in front of us is the flow chart of the logic that we want the program to deliver. Let us quickly understand how can I achieve it syntactically. This is the code snippet that you have in front of you. So using the declaration statement, I'm assigning the variable n, which is int in nature, the value 10. I then pass it to the if condition. Now, if condition, like I said, is always written using a set of parentheses. And if this condition evaluates to true, this part of the condition will be executed. If it does not evaluate to true, which is the else part, this side of the condition will be evaluated. So I'm taking care of both the true as well as the false behavior or false flow of action of my program. The curly braces that I'm using immediately after the if and immediately after the else signify the scope of those coding statements. So this is one statement. I can have multiple statements. And again, in else, there's just one statement. I can have multiple statements here. If there is just one statement, I did not enclose it in the curly braces, but it is a good practice to do so, so that if later on you have to update your code to include more than one statement, then your code will not misbehave. Okay, so this is how my if-else statement would look syntactically. Now let us consider a situation where I have multiple conditions to take care of. If something is true, else something is true, else something is true, else nothing is true. Now here there is a ladder. This ladder is referred to as if-else ladder. Let us quickly do an example to understand how to handle this kind of business requirement syntactically. But what we are going to do is we are going to quickly add a class into a package. So I'm going to add a package. Let's call it chapter 5. And in this class, in this package, I'm adding a class. I will call it meal options. I'm going to take a number from the user, and depending on the number that is given to me by the user, I'm going to print that user's meal alternative, meal selection. So I'm going to add a variable here. Let me just say int option. I'm not assigning it any value. And I think that will pretty much take care of what we want to do. I'm going to create an object of the scanner class. So what happens when you create an object of the scanner class? You are able to capture the input that is coming to you from the console. But before I do that, let me just quickly add a public static void main method to it. Public static void main. I can give it any name I want. And let me just take the scanner class object inside. All right. And I'm using the constructor. We will discuss the constructor and everything else pertaining to object creation little later. But this is the syntax that I need to use if I want to create a scanner class object. Now, as you can see, I'm getting a compilation error here. I'll go to the compilation error. I'll just take my cursor to the place where the error is highlighted. And I see scanner cannot be resolved to a type. Now, this is because scanner class exists in java.util package. So I need to import that package specifically so that the class inside that package is available to my current class. So let me quickly go to this place, add an import statement, java.util, and I will specifically add the scanner class. I can say java.util.star, and that will import the entire contents of the package util into my current class. I don't want that to happen. I'm only interested in scanner class. So I mention only that class name. So my scanner class is in place. Now let me quickly put out a message to the user, and I will say, select one for vegetarian meal. And I'm going to copy the same thing. All right. Select two for non-vegetarian meal. And select three for, let's say, a vegan meal. Okay. And then I'm going to capture that input into the option variable. Right. And I can take this here as well because anyways, I'm not using it outside. anyway. Option is equal to sc dot next int. I'm capturing the int value. So now whatever option my user suggests to me, I'm going to capture it in this variable. And now I'm going to write my business method. So let me write my business method. I'll say public void display menu. And inside this, I'm going to take an argument OP. Now if I'll say if OP is double equal to 1, so it means my user has selected vegetarian menu. Selected. Else, if OP is double equal to 2, it would mean that my user has selected a non-vegetarian menu. Right? I'm creating an if-else ladder here. Else if OP is equal to double equal to 3, it would mean my user has selected a vegan menu. Else, which would mean that my user has put some altogether random value. I'll say input option does not match the meal choices. Okay, this what we see in front of us is the if-else ladder. I'm going to save my program and let me quickly create an object of the very same class, meal options mlobj is equal to new meal options. Once again, let us remember that we are doing OOP programming. OOP, so we cannot have our business method, everything put inside the main. So we have created a different method. This is called compartmentalizing your code or modularizing your code based on the different functionality that exists. Okay, I have my object in place. Let me call display menu option, and to that I'm passing this option variable. This is how my program looks like. I'll be starting from here. I'll be taking the menu option from the user, sending it as an argument to my display menu method. Within the display menu method, I have my if-else ladder. Depending on the choice that my user has done, I will print the option of the menu which corresponds to that choice. And if it is not 1, 2, or 3, I will say you have selected something else. All right, let me just run this and see. Oh, here it is. So I'm asked to choose a menu. Let's say I choose 3. Vegan menu selected. So this is how if-else ladder works for me. So if I have to handle more than 2 cases wherein it is more than if-else situation, I can prefer to have if-else ladder. But what if there are too many alternatives that I need to flow through? And at that time, if I keep adding if else, if else, if else, it would become very confusing for me as a coder and for anybody else who reads my program. So a simpler alternative to all this is the switch statement. Switch statement has gone through number of evolutions over the period of time. This is a quick walkthrough of what we discussed just now. So we are going to discuss the important evolutions of switch between Java 7 to Java 17. Let's see what it was. So primarily when Java 7 was there in the market, we could only pass int value to the switch statement. And this is how the statement looked like. All right. So let us understand what we are doing here. I have an int variable called month. I'm giving it some value. It is 6. I'm going to pass this variable through the switch statement. And whenever I find a matching value against the case labels, I'm going to stop there flow through the labels and print the nearest sysout statement. The month is 6th, so it is going to be a 30 days month, and that is exactly what will be printed once I execute the switch statement. But let's say I pass something that does not match the available case labels. In that case, I will execute the default case and print the message invalid month. Now, what happens is when you're using switch as a statement, you first have all the possible case options, every case corresponding to one particular value. What we see here in front of us is called as the flow through, okay, or fall through. So even if I have 3 as a matching value, it is going to go from this point, that is the matching point, to the nearest executable statement. And if there is a break statement after that, the flow will break. Otherwise, it will continue till the end of switch. This is how switch becomes little tricky. First thing that you need to remember is to put the right values for the case labels. Secondly, you need to remember to put the break statement at the correct position to break the flow. Thirdly, as a good programming practice, you need to remember to put the default case. When you use switch as a statement, default is optional. Going ahead, we will see such examples where default becomes mandatory in switch. So far, let us just go with the flow and say that default is optional. All right, so I have the 6 number, value 6, through the variable month, and I'm going to pass it through the switch statement. Switch statement begins with a curly brace within which it has got as many case labels as you want, and it ends with a curly brace. Okay, I haven't shown that in the code snippet here, but you will have to end it with a curly brace. Okay, so I'm passing it. I compare my case labels. If I find something matching, I execute the code that is corresponding to the matching case. I execute the break statement and end the flow of switch. Because I do not find anything matching right now, I'll go over to the next combination of case values. There I find something matching. I'm going to say 30 days month and I'm going to break it. Let's say I pass 2 instead of 6. I will execute the case label 2 and say it could be month February with 28 or 29 days, and I will break the flow. And like I said, if I don't find anything matching, I'm simply going to execute the default label. This is how your traditional switch statement works even now if you pass int value to it. In Java 7, it was only int value that you could pass. But from Java 8 onwards, we could legally pass string and enum values. So enum was introduced in Java 5 itself, but by Java 8, it got officially incorporated into into switch statement. Let us see what we're doing here now. So now here, the month variable has become a string variable from int, and it holds the value Feb. I'm going to pass it to the switch statement. Now, because it is Java 8, I'm allowed to pass string value to the switch statement. I'm going to compare the possible alternatives of the 31 days months. Now, because it is Feb, my my switch is not going to find any matching cases here. So it is going to go over to the next case combinations. I have April, June, September. I forgot to add November here. But anyways, I have April, June, September. Again, it does not match the incoming value. So I'm not going to execute this chunk. I will go ahead. Yes, I find a match here. I'm going to execute February can have 28 or 29 days, break the flow. If I don't find anything matching, I'm going to execute the default case. Again, I'm still using my switch as a statement, so default is optional. I'm passing February to the switch, do not find anything matching, so I do not execute this. In case I find matching, I execute, break. This is pretty much how switch statement works. The only thing that has changed is the incoming data type. From int, we have now progressed to allow string. And again, we have also allowed enum in the same Java version. Enum is a collection of constant values which is declared prior to its use. So my enum here is months and it consists of comma separated values. So I have names of the months here. They are comma separated enclosed within curly braces. I pass one of those values to the switch statement. Enums were officially allowed from Java 8. So I say the name of the enum dot the value and I pass it down. So now my switch is going to see whether I find SEP as a matching case label. So I go through this, I don't find anything. So I'm going to ignore this part and I'm going to go down. Yes, there is this SEP. So I'm going to execute this and I say 30 days month. I'm going to execute the break. If I would have passed Feb, here months.feb, my flow would have come here. I would have said February. I would have executed this statement, executed the break and ended. And like everything else, if I have a default in place and no matching case, I execute default. So this is pretty much how we use enum with switch. Now going ahead, the next bigger implementation or the bigger change in switch came across Java 12, where the first thing that was allowed is the return value from switch block using yield keyword. Now, this is very, very important. And this is exactly the time where switch statement changed from being a statement and converted itself into an expression. So it was an expression which could return a value. So if you see, even the way we are using switch has changed now. It is returning a value and it ends with a semicolon. So this is something that you will have to remember. If you see this syntax, it is switch expression. And switch expression has to be exhaustive. When we say exhaustive, it has to put all the possible matching cases that it can, and it has to have a default case in case no matching case is found. If you forget to put default, you will get a compilation error saying switch expression is not exhaustive. So this is one more thing that we need to remember when we use switch as an expression. All right, let's see what we're doing here. Now we are going to understand which day of the week it is. And if it is between Monday to Friday, we say, oh, it's a weekday. And if it is Saturday, Sunday, we say it's a weekend. So I'm still passing string to the switch, but the switch is behaving differently because it is now returning a value instead of printing it then and there. And whatever value it returns, I'm going to print it outside the switch. So I pass Wednesday to switch. I compare it with all the possible alternatives. I find a match here. So I return the value. Now I do not use the statement return, the keyword return. I use yield keyword. So I return weekday, and then if I don't find anything matching, I said, oh, you have sent me some unknown day of the week. And whatever is the return value, it gets captured in the yield. I end it with a semicolon, and that value gets stored into the S variable, S reference string object, and it is printed here outside the switch block. So this is how we return a value using switch expression. This was the first change which was official by Java 12, Java 13, Java 14. All right. Next, we have multiple values for single case label. If you have noticed, our previous switch had separate labels for Monday, Tuesday, Wednesday, Thursday, Friday, when actually all these were weekdays. So what I do is, with the new addition to switch expression, I can have a comma separated case label list. That helps in making my switch expression compact, saves me space, makes my code better. I'm still doing the same thing. I'm passing some value to the switch expression. It is finding a matching case if at all. If it finds a matching case, it sends that return value in the yield. If it does not, it executes the default case, sends unknown, and ends with a semicolon. And whatever value is passed from the switch expression, I print it outside. So look at this code. It's become compact. It's better now. And it is comma separated list of values. So this is how my switch uses multiple values for a single case label. This was another addition which was officialized in by Java 12. Moving ahead, by Java 14, in addition to the return value and multiple values for single case labels, I now had use of arrow operator allowed within switch expression. I'm going to continue doing the same thing, but my approach of handling the case is going to be different. I'm passing Monday as my value. It enters the switch expression, but now after the comma separated case labels, look at what I have. I have my arrow operators. Arrow operators point to the exact code statement or statements. Yes, there can be multiple code statements here. They have to be enclosed within open, close, curly braces. So my comma operators point to those statements which have to be executed in case of matching labels. So that is what I do. I use a comma operator. I execute the code which is referred to the operator, pointed to by the operator. If I find a matching case, that value is stored in a variable, and that variable or object is printed. Please make sure not to include yield now. I don't need any yield keyword. So that is what my operators are doing for me. This was the next enhancement done to switch. I'm sorry, there's a spelling mistake here. My bad. All right. Moving on. Java 17. Java 17 added more prominent features to switch statement, giving it an upper edge over everything else. They included pattern matching. Now, previously, or apart from the switch statement, if I have to do pattern matching, I have to make use of instance of operator. We are going to discuss this operator in our future videos, and that time, if you come back to this video, you will be able to see how easily switch has incorporated this feature into itself and why this addition is so significant. So let's understand what we are doing here. I have one object of meal options class. I have another object of test class. We have written these classes in the some time back. So these are the two objects that I have. I create a reference of the object class. Object class is the mother class. It is the parent class of all the classes that we write in Java. So I have just created a reference. I haven't assigned it any specific value so far. Next, I assign it the value, or I make it point to the test class object. Let's assume just now at this point in time, let us just say that by doing this, I make obj become an object of the test class. Okay, so obj is pointing to obj_tst, which in turn is an object of the test class. Okay, so obj is an object of the test class. All right, and now because of the pattern matching feature of switch statement, I should call it expression actually, in Java 17, I'm actually allowed to pass an object. So imagine we started by just allowing int value, then we went to string and enum, and then we went over and we've come here to passing objects within switch. And then I start comparing all the possible classes and I say, okay, does this object belong to meal options class? It doesn't. So I cannot execute this code which is pointed by the arrow operator. I say, all right, does this belong to the test class? It does. So what I'm going to do is I'm going to actually invoke the message method within the test class and pass it this string. That is how my switch case not only finds the matching class for me, it actually uses that object to invoke the business method and execute that business method. So this is a very, very useful addition to switch statement. It saves me a lot of time. It allows me to have an alternative to the instance of operator, and I can get to do what I want to do. So this is really a very good addition to the switch statement. If I do not find any matching object, I say, okay, you've sent me some unknown class object, and I use the default case. I end my switch. Now, this is how you use pattern matching in Java 17 using switch expression. So if you're trying this expression, if you're trying this code snippet by yourself, make sure that you have Java 17 or above installed on your system. Okay, let's go ahead and understand what are the other features that Java 17 offers to us with respect to the switch statement. The next thing that it does is it allows me to have null cases. Very, very important. If I'm passing an object to the switch statement, to the switch expression, there could be a possibility that my object is null. This is the place, this is the situation where I get null pointer exception in my code. So yes, null objects perfectly fine. They happen, they can be passed. So what if I pass a null object to my switch expression? I compare that object against all the available classes that I want to compare it to, but I also have a null case. This is the difference between the previous example and this example. I have a null case. So in case I have null object coming to my switch case, I can do something with it. In this case, I'm just printing, okay, you're sending me a null object. So I print it and I move on. If I wouldn't find any matching cases, I execute the default case. Let me remind you that if I'm using switch as an expression, my default case makes it exhaustive. It is important, mandatory even, to write this in my program, in my switch expression. Okay, this is how far we have come. We say that now I'm able to pass an object, I can implement pattern matching, and if that object is null, I can even have a null case option available for me. This pretty much wraps up today's discussion on the decision makers in Java. When we use these decision makers, we have to understand all the possible flows that can happen in the execution, during the execution of our program. And only when we consider the number of flows, we will be able to choose whether we want if else, if, that is the if else ladder, or we want to go ahead and use switch statement or switch expressions in our language. If you're using Java 21, you will be able to use all these examples, copy these snippets into your own code, execute your code, and see for yourself what are the different results that switch statement gives to you, depending on what you are passing to it and how you want the statement to behave. Learners, thank you so much for watching this video. I hope you're enjoying the video lectures. In the next lesson, we will discuss the code blocks, the data types, and type conversions in Java. So stay tuned for the video update. And if you still haven't clicked on the like, subscribe, and share button, please do so now. Thank you so much. See you in the next video.